My name is Megan Johnston, and the name of the experiment that I did was Effects of Heat Energy on State of Matter. So what I did was I took regular water, boiled water, and twice boiled water, and I filled them up in ice cube trays, and I put them in the freezer, and I tested the clarity of each type of ice cube. So my hypothesis, or my question statement, was what is the effect of heat energy at the time of freezing on the clarity of the ice cubes being produced? My outcome statement, or what I predicted, was that the ice cubes made from the twice boiled water and the regular boiled water would be more clear than the ice cubes made from regular tap water. And I thought that because when I think of something being boiled, I think of impurities being dissolved or going away. So I figured that after the water was boiled or twice boiled, the ice cubes might be a little more clear because it would have ridded them of some of that debris. My content statement is this experiment is about how heat energy affects different states of matter. So the heat energy being the water being boiled, the boiling of the water, and the states of matter being liquid and solid. So from water being water, a liquid, to being frozen into an ice cube. Some key vocabulary that was important for this experiment was temperature, which is a measure of the average motion of matter. The faster the movement, the temperature will increase, and the slower the motion, the temperature will decrease. Heat is the transfer of thermal energy from a hotter object to a cooler one. Convection is the flow of energy through heated liquids or gases. Matter is anything that takes up space and has mass. And there are 4 states of matter: liquid, solid, gas, and plasma. The 2 types of matter that we focused on in this experiment was solid and liquid. And a solid is matter that has a different shape or a definite shape and a definite volume. And a liquid is matter that has a definite volume but no definite shape. This content is important because it will be exploring the convection at the time of freezing on the clarity of the ice cubes being produced. So the different types of variables that I used in this experiment, the manipulated variable was the type of water, which I used tap water for all of it. Just I boiled some and twice boiled some of it, but it all came from the same sink, the same faucet. My responding variable is the clarity of the ice cube. And my constants are the water source, the temperature of the freezing, and the type of ice cube tray that I used. And this is the type of ice cube tray that I used, just a regular plastic ice cube tray. The materials that I used were ice cube trays.
Good afternoon, Brantford Elementary School. It's my pleasure to announce Brantford Elementary School School-Related Employee of the Year, Ms. Crystal Cox, in our cafeteria. I'd also like to announce Brantford Elementary's Teacher of the Year, Ms. Amy Allen. Congratulations to both of those ladies.
So the materials that I used were ice cube trays like the one that I just showed you. I have 3 of those that I used. Water, the stovetop, a saucepan, a freezer, clear tape, and permanent marker. And I used the clear tape and the permanent marker to label each one of my ice cube trays. So the procedures that I did, I first set up the ice cube trays and I made sure that they were clean of all debris. And I set them up just by putting the tape and labeling each ice cube tray. Then I used the saucepan and the stovetop to boil the tap water. And I used enough water to fill up 2 ice cube trays. While the water was boiling, I filled up my 3rd ice cube tray with just regular tap water. And then after the water boiled, I used that water and filled up my 2nd ice cube tray. And then I returned the pan back to the stove and I continued to boil again. And then after the water boiled again, I filled up my last ice cube tray with the twice boiled water. After that, I put all 3 trays into the freezer and I let them sit in the freezer for about 2 days to make sure that they were solid. And then after they were completely frozen, I took them out of the freezer And I took 10 ice cubes from each group, and I rated them using my cube rating rubric to record the clarity, and I recorded all the data. So this is my first observation from the regular tap water. This is my ice cube tray that I used, and you can see here that the ice cube is very cloudy. This is from my boiled water, and you can see the ice cube is not quite as cloudy as the one from regular tap water. And then this is my last observation from the twice boiled water, and this is a side view of it. You can see the clarity at the front of the ice cube, and then it's more cloudy towards the back of the ice cube. This is my ice cube rating rubric. I rated each type of ice cube on a scale of 1 to 5, depending on how cloudy or how clear each ice cube was, and I used 10 ice cubes from each regular tap water, boiled water, or twice boiled water. And this is the data. For regular tap water, I had an average of 2.3. For the boiled water, I had an average of 3.6. And for the twice boiled water, I had an average of 3.4. This is the data for the median, mode, and the range. So for the median, for the regular tap water, I had a 2. For the boiled water, I had a 4. And the twice boiled water, I had a 3. For the mode, the tap water was 2.3, the boiled water was 3.6, and the twice boiled water was 3.4. In the range, the tap water was 2, boiled water was 1, and the twice boiled water was also 1. So this is just the graph comparing the average of each of the types of ice cubes. So the results that I found from this experiment was that the average clarity of an ice cube made from regular tap water is 2.3. The average clarity of an ice cube made from a boiled water is 3.6, and the average clarity of an ice cube made from twice boiled water is 3.4. And all of these results are based on a scale of 1 through 5. So the conclusion to this experiment was that I found out that convection does not have much of an impact on the state of matter, or the clarity of state of matter. The ice cubes made from regular tap water were cloudier than the ones made from boiled water and twice boiled water, but it wasn't significant. Although boiling water will dissolve impurities in tap water when freezing it, those impurities will separate themselves from liquid and become visible and congregate towards the center. And you can see that in my observation picture from the twice boiled water. It was clear towards the front of the ice cube, and then towards the back of the ice cube, where it got cloudy, that's where all the impurities congregated together. So this could be used in the real world with different businesses, like restaurant businesses and drink businesses, when they're making these new fancy drinks. A lot of these places want to go all out, and so they'll use these nice crystal clear ice cubes that people can't typically make at home because it makes their drinks look prettier. So this is my narrative diary. On October 8th, I decided on my experiment and I emailed my professor. On October 10th, I went to the store and bought all the supplies that I didn't already have. On October 16th, I set up all the ice cube trays and I boiled my water and filled all of my trays up and put them in the freezer. On October 18th, I set up my rubric. On October 18th, I also took out all the ice cubes and I observed 10 ice cubes from each tray and recorded the data based on the rubric. And on the 21st, I finished my conclusion and my real-world application. Thank you.